Alright, greetings and salutations fellow YouTubians. Almanzo again. Okay, so how strong is the assembly? I think practical demonstrations are usually the best. So I place my own safety, life and limb out there for you to show you that when I design these things, I design them to be as bulletproof and as strong as is possible and practical. In this case, it was extremely challenging. Very limited thread engagement, some oddball angles, very small hardware, but well, I think you'll see. The results kind of speak for themselves. So, I have the assembly up here. I apologize for being so far away. I will give close-ups of this to show you that there's no trickery or camera tricks or editing or, you know, or any connivery going on. So yeah, this is the neck cylinder, functional neck cylinder. Got a piece of angle iron up here. Got it kind of screwed in up there. Parallel bar here, 832 bolt going into the bottom here. And I would like to point out that the bottom coupling, the top one is at a 25-degree angle, obviously. The bottom one, though, is straight. So when this, you know, has weight on it, it is actually pulling straight down. So there's no possibility of it binding. So if it was going to fail and, you know, pop out of there, it would just pull straight out. There's no offset going on there. So, okay, I'm still in frame. So, how to demonstrate how much weight this will hold? Well, here it is. Me. So, here we go. Break a leg, right? So, there we go. Over 200 pounds of weight on there. It held it just fine. So, I'll grab the camera now and give you a close-up. And I'm also going to be taking this, disassembling it, so you can see that there was, you know, that all the parts are the actual parts and that there was nothing, you know, stupid going on. Okay, I can still see my camera. So yeah, there's the assembly. So, and actually, ooh, close call there. You can see this actually kind of will slip right out of that hole there, but you can see there's actually not a lot of thread engagement there, and actually works out pretty good because I could just grab it. So let me grab the tripod. I'll keep this right in frame still. Okay, and here, and let's get this right, get this close again. I apologize for the crudity of my videos. And there's that. And whoops, don't lose. There we go. All right, so there we go. So here, I take this apart. These are not, you know, Loctited in here or anything like that. You can actually, and they're not cranked in. You can see that, for God's sake. There. Set screw there. These are 632 1/4-inch long set screws. I can just pop out the core. You can see it's the actual core. Here's the ball. Set the core here. See, again, none of this is, you know, 832 threaded into the nylon ball. Yes, it is nylon. It's a little bit dirty because of the aluminum makes it, you know, discolors it. And then down here, and I actually on purpose put the bottom one down here because it's the one with even less material. And you could see, you know, when I hung down on it, it was, you know, it could pull. Whoops! It could pull straight out. So, and here, go here, and go over here. There we actually, I can just pop that set screw out. There's that one. There's this one. And I'll pop this out, the core here, and I'll try to show you on camera. There's not a lot of threads there at all. I mean, if I put my finger down at the bottom and then just unscrew this, right there, that's all the more threads that hold that in there. So, yeah, and there's the core. You can see the threads didn't deform or anything. And that's the way I designed it. And down here, this one, I don't think, wait, yeah, if I push the ball in. Oops, let me see here. If I can get my finger in there. There we go. And there's that. You can see it's just that's actually just a countersunk screw there, 832 into the threaded nylon ball. And yeah, so that's it. And I get questions. On the Johnny 5, are these cylinders hydraulic or pneumatic? Duh, they're hydraulic. It uses fluid because here's a simple thing. If I plug up one, if I do this, you can see it moves in and out. If I plug up this port, yeah, see? Air's compressible. Fluids are not. You need fluids in there to be able to precisely move this thing. Otherwise, this thing's just gonna go full up or full back. That's why you use the hydraulic. So yeah, there it is, folks. The proof's in the video and in the pudding. Oops. These little tiny puppies there. They here, I'll pull this screw out of here. There we go. And see? That screw itself is only yeah, 1/4 inch long. So it was designed so that the center screw is captured on the sides also by the set screws. So it's a really strong assembly. So there it is. Okay, so get up off the ground here and get out of the way of that bright light. So I live. And I think from now on I should be called Almanzo the Great. Yes, I like that. Okay, so there it is, folks. The system is strong. It will last a lifetime easily. This was like a crazy beyond anything you would ever experience on the robot. But yeah, any other method, would it be strong enough? Yeah, well, if you can't hang off of it like I did, then yeah, you might want to reconsider what you're doing. So this is the way to go. This is why I designed it this way. It will not fail. The head will not come crashing to the ground, and it's an investment in what you already have into the robot. Very expensive, and I don't want to see anybody's robot getting damaged because there was a design flaw or just something that wasn't what it has to be. So, all right, talk to you all later. Almanzo the Great saying bye for now.